Okay, hello everyone. Good morning. Okay, so today we will continue on chapter 7. Okay, work, energy, and power. Okay, so on Friday. Okay, so on Friday we will discuss all the tutorial that I already give to you. Okay, for you to answer. So I hope you are prepared. Okay, for the answer. Alright, so we go to the next chapter. Okay, work, energy, and power. Morning, Junyuan. Okay, so work, energy, and power. Okay, so what is actually work? Okay, so work is a energy used to move or change an object. So let's say if you have a box, okay, so if you pull the box, okay, so the box will change the position. So it means you use the energy, okay, to move the box, okay, or to change the position of the box. So it means you do work, right? And then the SI unit for work is a joule, okay, J or Newton meter. Okay, so this is the unit SI unit for work. Okay, so whether you can put joule or you can put Newton meter. Alright, so this is a formula. Okay, work is actually equals to force. Okay, so the force, the unit must be in Newton. Okay, and distance, okay, must be in meter. Okay, work is a kind of energy transfer. So why you said that the work is a kind of energy transfer? So example, let's say if you have a box, right? And I just told you just now, if you want to push the box, okay? If you want to push the box, all right? So inside of your body is already you have a chemical energy, okay? So it comes from the food that we eat, okay? So the chemical energy, all right, so when you push the box, so the box will move. So any object that move will have the kinetic energy. So me from your body, okay, it's transfer the energy to the box, okay, and it become the kinetic energy, so that and the box can move, right? So that's why it said what is a kind of energy transferred. Okay, what is done if an object acted upon by a force, okay, move in the direction of the force. So let's see if I have an example here. Okay, so this is the box. Okay, so I push the box, okay, with the force F, and then the box will move, right? So it will move in a certain distance. Okay, so if the box move, okay, in the same direction, okay, in the same direction as the force given, okay, so we call it the work is done. Okay, so the box must move with the same direction as the force. Okay, so then we can say the work is done, right? And definition of work. So what is the product of force and displacement in the direction of force? So W is equals to F times S. Okay, force multiplied by displacement. Okay, and then if you want to know about the unit, so the force must be in Newton. Okay, and S is the displacement must be in meter. So should be Newton meter. So that's how you get Newton meter just now for the unit. And also if you want to simplify it, you just can put J, okay, as joule. Okay, so that is the definition of work. So what is the product of force and also displacement? Or you can say force multiplied by displacement also can be accepted by the for the answer. Okay, so this is the formula. So the SI unit of work is joule. Okay. So what does it mean by 1 joule? Okay. So 1 joule means the work done, okay, for a force of 1 Newton, okay, is used to move an object over a distance of 1 meter in the direction of force. Okay. So what does it mean here? So we can say that we do 1 joule of work, okay, 1 joule of work if you give a force, okay, if you give a force 1 Newton, okay, and the object will move in 1 meter. Okay, so You say here you give like 1 joule of work if you give 1 Newton force to the object and the object will move in 1 meter. So that's the meaning of 1 joule. Okay, so units of Newton meter is used to measure a moment of force and energy, which are two other physical quantity other than work. Okay, kilojoule and megajoule. Okay, so let's say sometime if you got, when you calculate, right? So let's say you calculate the word. So you got the answer like 3, okay. So you got like this, okay? You calculate the word, you got like this. This is the answer. So if you know this one, there's too many, the answer is very long, right? So how you want to simplify it? So you have to change to standard form first, okay? So 1, 2, 3, 4, 5, 6, okay? So it got 3 times 10 power of 6. So if you learn in, you already learn in form 1, okay, for prefix, right? Kilo, nano, micro, okay, deci, centi, milli, right? So 10 power of 6 is actually is equals to mega, okay? So you can just put 3 megajoule, okay? So you just simplify the power here, okay, 2 mega, okay. So you have to refer to the prefix, okay, the prefix table, okay. What is the value of 10 power of 6? So 10 power of 6 is mega, so you just put megajoule, okay. So that you can also answer in that form, okay, in the prefix form. All right. So example of the work done, okay. So the first, pushing a shopping cart. Okay, so for a work to done, there must be a displacement. There must be a distance. Okay, so let's say if pushing a shopping cart, okay, of course the cart will move. Okay, the shopping cart will move. So when you move, mean it has a distance. So means the work is done. Right? So let's say if you push a wall. So even you push a wall, how hard you push a wall will not move. Okay, so mean there is no work done because the wall is not moving. Okay, so in order for you to say that the work is done, there must be a distance, okay, for the object to move after you push the object. Okay, so let's say this is the example, pushing a shopping cart. So when you push the shopping cart, of course the shopping cart will move, right? So will move in a certain distance. Okay, so this is called as the work done. Okay, or work done by the brake when the car stop, right? So when you step on the brake, okay, so you will take like a few for sometimes for the car to stop. So the moment you want to stop the car, okay, the distance it take to stop the car, okay, it is called as the, also we can say the work is done, okay, because there is a distance, okay. And also weightlifting. Okay, so if you want to lift a weight here, okay, so if you want to lift a weight here, so of course there will be a distance, right? So it will be moved upward. Okay, so mean there will be a distance. So this one also we call it as a work done. So basically for a work done, there must be a distance. Okay, there must be a distance. The object must move. Okay, must move from point A to point B. Okay, so that's the example. Okay, example of work not done. So the object that is acted upon by a force remains stationary. So it means not moving. So example here, they give a woman is pushing a wall. So the wall is not moved, so means there is no work done. And another one, the example, so the waiter walking towards the diner. Okay, so it says here the direction of motion of object is perpendicular to the applied force. So you lift up the glass here, right? So means the force is upward. Okay, but the way you move, the direction of the movement, okay, is to the right. So it's a perpendicular. So when it's a perpendicular, so means there is no work done. Okay, there is no work done. Okay, there is no work done. So you must the direction must be parallel. So let's say just now, like I say, if I have a box, then I push the box. Okay, so this is the force, and also the direction of the movement also is to the right, right? So mean this is the work is done. For this one, the force is actually upward, but the direction is to the right. So this one is perpendicular to each other. So this one, the work is not done. Okay, the force and the direction of the movement of the object, okay, must be same. Okay, must be parallel. Okay, so that we call it the work is done. Okay, example of work done. Okay, the first one, lifting a box from the floor. Okay, so just same like the weight lifting just now. Okay, the force is going upward and also the direction of the movement of the weight also going upward. So same direction, right? So means there is a work done. Okay, and climbing a flight of stairs, right? And compressing a spring. Okay, rowing a boat and also climbing a tree. So basically what we can see here, all the object, okay, that involve, there must be a movement. Okay, there must be a distance of movement. So then we can say the work is done. So example, when no work is done, okay, pushing hard on a box which does not move. So let's say the box is too heavy and you try to push it, okay, and it will not move. So mean there will be no work done. Okay, even how hard you give a force to it, okay, but it's still considered there is no work done. Okay, standing still with the load on one shoulder. Okay, so let's say this one, if you take your bag, okay, and then just standing there, okay, that means they consider there is no work done because there is no change in movement or change in the distance. Okay, watching the Olympics on television. So this one, of course, you are not moved. Okay, so no work is done. Okay, pressing a heart against a wall. So this one we already discussed. And sitting on a bench. Okay, so this is the example, okay, where no work done. Alright, so for this one, actually we have to use this formula. Okay, force multiplied by displacement. Okay, but as you can see here, all the force that been given is in the straight line like this. But for this one, okay, the force is inclined like that. It's not a straight line. So what you have to do, you need to find the force first that move in the straight line. Okay, so means here you have to find the force in this direction. You have to find here F. Okay, so how to find the F here? Okay, before you use in this formula, okay, because work you have to know the force, then you have to know displacement, then you can calculate, right? Okay, so for this one you have to find F first. So I'm not sure whether you already learned about the trigonometry. Okay, so for the trigonometry, it involves the right angle triangle, means 90 degrees. Okay, so I will draw the triangle first, the right angle triangle. So this is the triangle. All right. Okay, so I draw it again. So this is 40 degrees. Okay, this is 10 Newton. So remember what I want you to find. You want to find F here, right? Okay, so after that, okay, what is the relationship between the angle and also this side? So this is called as the adjacent. Okay, and this is 90 degrees, right? So this is called as hypotenuse. So you should use cos. Okay, adjacent, hypotenuse, cos. So cos 40 is equals to adjacent is F. Okay, hypotenuse is 10. So how to find F? So this one is divide, right? So you change here, become multiply. So F 10 cos 40. Okay, so that's how you want to find F. Okay, so after that, you can put in the formula. So what is F here? F is 10 cos 40. Okay, so F is 10 cos 40. Okay, and then here, what is the S here? The displacement. The displacement is 5. Okay, so I think this one, the answer is 35 point something. Wait. So I got 38.3 joule. Okay, so that's the answer. Alright. So if the force is not in straight line, you have to find the F first. Okay, here, because this one it move in the straight line, right? Okay, even you know, like if you push the, if you pull the object here, if you pull a wooden block in this way, the block will still move in this way, right? Okay, so means you have to find F here. All right, so then I draw the right angle triangle, okay, here. Okay, then I label it back. Okay, this is 40 degrees. Okay, and this is 10 Newton, and you want to find F here. So then we find the relationship between the angle and also the side here. So this is adjacent, and this is a hypotenuse. So adjacent and hypotenuse is cos. Okay, so cos 40 is equals to adjacent is F, hypotenuse is 10, right? Adjacent divide by hypotenuse. Okay, I'm not sure whether you already learned this one or not. Okay, so adjacent divide by hypotenuse. So this one, if I want F, so this one is divide. Go, as we change here, it will become multiply. So 10 multiplied by cos 40. So this is F, then I just substitute in the formula. F is 10 cos 40, S is 5. Okay, then you just multiply, you will get 38.3 joule. Okay, so that's the real, that is how you want to do. Okay, if you got this like this. Okay, this question is like this. Okay, but okay, here the solution is wrong. Okay, you cannot just use 10 multiplied by 5. Okay, cannot, because the force is not in the straight line. You have to find the F first. Okay, so this is wrong. Don't follow this one. Okay. Okay, so the next one is the example. So can you calculate for me what is the work here? Work is force multiplied by displacement. What is the force here and what is the displacement? Anyone want to try? What's the answer for this one? (100 meter, 100 fs, 100). Okay, F is 20, right? And the displacement is 5. So you will get 100. But 100 is the unit. What is the unit for work? The work unit is joule, right? So 100 joule or 100 Newton meter. Okay. For Fs is actually, that one is the formula. Okay. You cannot use that as a unit. Okay. So 20 times 5, you got 100. So for work, the unit is joule or Newton meter. So let's check the answer. Okay, so you got 100 joule. Okay, so the next one is the energy. So energy is the ability of an object to do work. So let's say you don't have an energy, so mean you cannot do work. Okay, so energy is the ability to do work. Okay, so the SI unit for energy is same like work. Okay, there is a joule. Okay, when the work is done on an object, the object gains energy. So remember that I told you just now, right? So if I, instead, usually we already have the chemical energy, okay, based on the food that we eat, okay? So when I push the object, okay, when I push the object, so now the object at the first, it does not have any energy, okay? Then when it start to move, it has the kinetic energy. So where does the kinetic energy come from? So it's actually come from our body, okay, from the chemical energy. So then the work is done, the object gains energy, right? So the object start move means it has a kinetic energy. So 1 joule of energy is used, okay, when the force of 1 Newton is used to move an object, okay, over a distance 1 meter in the direction of the force, okay. So let's say we can say here, we do an energy, okay, amount of energy that we use is 1 joule. If you apply, okay, 1 Newton of force, okay, to move an object in 1 meter. Okay, so we can say that we did 1 joule, we did 1 joule of energy if we apply 1 force of Newton to an object and it moved in 1 meter. So that is the meaning of 1 joule. Okay, so the next one is a power. Okay, so what does it mean by power? So power is the rate of doing work. Okay, so this is the formula for power. Power is work divided by time. Okay, work divided by time. Okay, so the SI unit for power is watt. It's just same like the electricity. Okay, in the electricity also when we learn about power, the SI unit for power also watt, right? But the formula is different. Okay, for the power is P, for the electricity is P is equals to VI. Okay, but for energy, okay, for the force is power is equals to work, okay, divide by time. Okay, but unit is the same. Both is watt. Okay, so power of 1 watt is used when the 1 joule of work is done in 1 second. So we can say the power is 1 watt. Okay, if we do a work, okay, in 1 joule, okay, for 1 second. So means in 1 second you do work, okay, that amount of work is 1 joule. Okay, so that's the meaning of power. So this is the 1 watt is equals to 1 joule second. So how you get 1 joule second? Okay, what is the SI unit for work? Joule. Okay, what is the unit for time? Second. So it's actually JS negative 1. But if you want to simplify it, we can put watt. Okay, so that's how you got JS negative 1 here. Okay, based from the formula, work is joule, time is second. So JS negative 1. So 1 work is actually equals to 1 joule, second power of negative 1. Okay, so this is the first example. Right, so a student of mass 60 kg runs up a flight, okay, of stairs of height 5 meter in 8 seconds. Calculate the useful power developed by the student. It says here 1 kg 10 Newton. Okay, now we already know the power is P is equals to W over T. But in the question, they didn't give you any work. Okay, the magnitude of work is not given. The value of work is not given. So mean we have to calculate the work first. Okay, so what is the formula of work? Fs, right, over T. So the force, okay, can you find force here? There is no force here because force is Newton. Okay, as you can see, there is no Newton in the question. Okay, but it says here 1 kg is equals to 10 Newton. Means you can convert the mass to the force. Okay, so here if 1 kg is equals to 10 Newton, if 60 kg means it will be 600 Newton. Okay, so now we have the force already. Okay, remember the force, the unit must be in Newton. If there is no Newton there, means there is a mass. You have to convert first the mass to Newton. Okay, so this one you got 600. Okay, and then the displacement, okay, so what is the height of the stairs? Is 5. Okay, and what is the time here? Is 8. Okay, can you calculate for me what's the answer? 600 times 5 divided by 8. 375, yes. So what's the unit for the power? 375 watt. What is the unit for power? Watt. Okay, so this is the answer. 375 watts. So let's check the answer. Is it correct or not? Okay. Yeah. So you got 375 watt. Okay, the next one. Okay, can you try to calculate for this one? This is the same as the first one. Okay, a man took 10 seconds to push a wheelbarrow, okay, filled with the stone, have a mass of 100 kg to a height of 2 meters above the ground. Calculate its power. 200 watt. Okay, very good. 200 watt. Okay, so P is equals to work divided by time. So there is no work given here. So you have to find first. So Fs, okay, T. So the force here is 10, 1 kg is 10 Newton, is 100 kg means 1000. Okay, 1000 Newton. And then it move, okay, what is the distance here? The displacement here is 2. All right, and what is the time taken is 10 seconds. So 2000 divided by 10, you will get 200 watt. Okay, so let's check the answer. Hmm. Yeah, correct. Okay, so very good. Right, so that's all for the work, okay, and energy. So I will give you a few questions. I will assign to you a quiz, okay, a quiz for work and energy. So I want you to answer, okay, in the Google Classroom. So you can answer in the Google Classroom and let's check, okay. So tomorrow I will see you back on Friday. So we still have half an hour. So I want you to answer the question, okay, that I already assigned in Google Classroom. So is it okay? Right. So I will see you on Friday, right? To discuss for the tutorial. Okay. So take care, class. All right. So see you on Friday. Okay. Stay safe, everyone. Okay. Bye. Okay. Welcome.